Hello and welcome back to Compiler Programming. Today is going to be another of sort of a talking head videos. I don't think I will do any programming today, but what I wanted to talk about is compile time execution. So here I have opened up the current implementation of compile time evaluation. I was doing a bit of cleanup yesterday and I noticed a problem with the way it works. I mean, there is a bunch of problems already here, but I noticed another one. And that problem is that we do not separate which values can participate in compile time execution versus which ones cannot. You can say that basically constants should be able to participate in any kind of computation, but I think it's a bit more subtle than that. So what I thought I would do today is I would talk about, at least from my understanding, how a couple of other languages deal with compile time execution. I believe I understand how it works like in Zig and how it worked like in Jai, although especially for Jai it's a bit hard to tell because there is no way to access the source. But I want to talk about that, and I also want to consider how it works right now in math and what my plan is for the future. Okay, so let's start with how it works right now. So I will say basically now, maybe I want to decrease brush size a bit more. Let me check if that is better. Okay, now. So now what happens is we have a data segment, right, and which contains all the globals, function pointers, imports, and whatever. And every time we do compile time execution, we clone that data segment, and we have like a copy here. And we do whatever we want, and we when we return a value from a compile time execution, that value returned goes back into here. That is perfectly fine, that can work. However, the obvious issue with this approach lies with the fact that we have to make that copy, right? It might be possible to do something fancy with native memory management like copy on write and whatever, or like implement it ourselves as a copy on write. So there could be a way to optimize this stuff, but I'm not sure I like it in general. And as I said, extra problem, there is a question that is about which vars are comp time. So what can we access from compile time execution and what is not allowed to be accessed from compile time execution? So this is a very open question. This is a bug at the moment because we can access everything, and I'm not particularly happy with that. So this is what we have now. Okay, let's talk about Zig language next. And this is just my understanding. I might be actually wrong about how it works, but from what I gather, there is like both math and Zig, they have constant folding, which means that if you know for example, if you have something like a plus, and you know that this is 4 and this is 2, the result will be 6. So if you come across this pattern in the code, you know what to replace it with. You can just remove all of these nodes from AST and replace them with 6. So from what I gather, the way compile time execution works in Zig is that it operates exclusively on constant values. And so if you say like const foo is 42, then this is something that can, and then foo is accessible in compiled execution. And it would, and then if you have a function call inside of compile time execution, so we say, I don't know, you have bar of foo. So what happens in this case is you take the body of the bar and you expand it, and you define, instead of arguments, you define constants, and you just follow up with constant folding. So I don't know, imagine that bar was function bar, whatever, it accepts, I don't remember the 6 syntax, but let's say it accepts S64, right? And bar does x plus 1. And return x plus 1. So let's say that this is what it does. So what will happen when you make a call is you will get into a scenario where you would have as if the program was written like x is 42, right? Because that's a value of foo. And then you say x return x plus 1. Since I already said that we can constant fold, we know that this is a const x is 42, and we know this, and we know that this will be 43, and so this is the result of compile time execution. Obviously, there is a bunch of things that need to be handled with non-primitive types, but in essence, this is how it works, at least to my understanding. This has sort of interesting implications about what is allowed and what's not. I still need to dig a bit deeper into it, but this approach has interesting implications because in a sense, compile time execution is not really running the function as it's doing constant folding, and maybe there is an optimization to be done later on, but this is my understanding at the moment. So then we have, for example, then we have, let me put it here, Jai. And Jai is interesting because, again, from what I can tell, there are no const. So no const values. It doesn't, it has the concept internally, but from what I understand, it's not exposed to the users. And instead, you only have sort of what is called declarative scope, and you have imperative scope, right? Imperative scope. And this is, if you're talking about compile and execution, you're, from what I get, talking about declarative scope. And this is where all of your compile and execution exists, right? And at the same time, it actually does the same thing as we are doing here. So you get a copy of the data, and whenever you do any kind of compile time execution, you will, like, even if you do something to this data over here, you are doing it to a copy, so everything is fine. So let's just say also copy data. So here are the things. As far as Zig goes, again, maybe there will be optimizations to how it's done in the future, or maybe I don't understand everything. But I'm not sure I'm in love with constant folding aspect of it. And I'm also not sure that about how to handle like constant folding. Basically, it means that compile time execution will be inherently slow, and I want to make it really, really fast, and I want to make compile time execution be the main sort of workhorse of the compiler, so that majority of stuff is done through compile time execution, and that's just not gonna happen if you basically doing interpretation over an intermediate representation and doing constant folding there. That does not seem to be to work out very well if I want basically everything like if, while loops and struct definitions, if I want everything of that to be compile time evaluation. This just does not seem like a feasible option. In addition, I might miss this stuff, so I need to look it up. I'm not certain how it handles mutable stuff. So this is, I don't know how it does that, but maybe it supports it, maybe it doesn't. So let's just say mute. If everything is constant, can compile time execution have some kind of global mutable state? And it's a big question. So yeah, coming back to Jai, I don't like basically this part. So on one hand, it doesn't really, as far as I understand, have constants as far as language semantics goes. So something that is imperative but not mutable. And second point again is this is a deal breaker for me, and this is again how it's implemented right now here as well. We just cannot copy the data. That would be way too expensive a thing to do. So that's a no-go. Okay, so if I don't like my current thing, if I don't like this and I don't like this, what do I want to do? Okay, so here will be the plan. And let's again pick out a new nice color. So we say the plan. Okay. Firstly, I want compile time execution to have nothing to do, well, it will have interesting relationship between constants and non-constants. So first of all, let's split up the execution. So we have runtime and we have comp time, right? And we have then, we have const and we have mute, and the same thing here, const, and the same here, mute. Okay. So, and we need to understand what is accessible from what and what should be the rule. And I think the rule will be that runtime and compile time can access each other's constant values, but they cannot access each other's mutable values, but both have both of them. And the way I want to achieve this is by splitting up. So first of all, the values themselves will, of course, will be marked as const, mute, whatever. So whether they're constant or not. And also, I think they will have to be marked as comp time or runtime, which is something that does not exist. Also, I'm not sure exactly that it will be on values, or we also will have to talk about scopes. So let's grab it maybe a bit over here. And let's just say scopes. So right now, and this is also kind of a difference, we actually might come back here. So right now in mass, there is just one scope essentially, or one type of scope as far as execution goes. So there is no difference there. In Zig, there are multiple types of scopes, but I think the only difference there is whether compile time execution is by default or not. But there is, as far as I can tell, there isn't a thing where a compile time value is not accessible in outside scope, but I might be wrong. But so here's still basically one type of scope. In Jai, there are these two things, but if you have compile time thing, this is also a copy. This is also copied, and this is more or less not accessible from compile time execution. So this means, and yeah, what I want to do instead is I want to do the same split. So in parallel in the program, we will have again runtime and comp. And if we want to share the value between those two things, then we will just make a copy from one to another, and everything is going to be fine. And basically, the copy in this direction goes when you have something declared its compile time. So for now, we have this double colon operator that defines some compile time value, or right now it's it's a mixture between constant and compile time, and I want to get away from that. So that might require actually changing the syntax of this stuff. But this is what would happen, right? So when we have a compile time constant value, you should be able to pull it into a runtime scope. And I'm not exactly sure how this will look like. We can have like a proxy entry that just points to this entry or whatever. This is a question. It might be an actual copy. I don't know what will be the right way to do it. But because this entry will be constant, it is safe to do so because we promise we will not change it. Then there will be mutable entries in this scope, and they are again not accessible, so they are private to this scope. You can manipulate them during compile time. An example of why that would be useful: imagine that you have I don't know, you want to just have integers that are sequenced, or you want to have unique IDs in your program. So you will have like an ID or next ID counter. This is not something that you want to access ever in your runtime, or like not directly access, but you can have a compile time function that will be like get ID, and this will take a look at this, it will increment it by one, and return you a new identifier. So this is something actually that is very useful. There could be a more complicated example where you manipulate, I don't know, arrays, and you store some things, for example, for running tests or whatever else you might want to do. But having mutable things here, I think, is very powerful to have. And as far as I can tell, that's not directly possible, at least right now in Jai, and I'm not sure about Zig. I think you can return things from functions, but I don't think there is a global mutable state either. Anyhow, so this is the relationship here, and then again, if you define a constant value here, this becomes a bigger question, how I want to materialize this in compile time scope. Maybe they will be automatically done. So again, when you define something as const, then it goes here. I'm honestly not sure. It might be that this is not gonna happen, and we will keep it to just being compile time, because constant at runtime just means that we promise that we will not change the value, but the actual value might be computed at runtime, right? So this is a bit of a different thing. So I think we will not have constants here. However, there will be definitely a way to go back to compile time and define something there. And this would be something that we already saw in the, I think it was the last video, which was reflection, right? When I have a runtime value and I want to know things about its, how is it stored? Is it stored in register, or what's its type, and so on and so forth? We do know those things at compile time. So when we do any kind of reflection, this is where things would be allowed back into here. There is like this part actually talks more about values, but the reason I was talking about scopes is because of the lookup rules, right? If on the top level we say something like, let's say provisional syntax, and we say comp time mute ID and 0, right? If you have something like that, then we should not be able to access this within functions. This is private to compile time execution, and you should not be allowed to touch this in any form in the runtime. The only way to get at it is to get a snapshot of this value by again having a compile time function. So we have comp time get ID, right? Which will obviously return ID. And the point is, when this thing looks up this identifier, it can look it up here. It will go from here. But if you have a regular function, so regular function foo, right? Like we have right now, then if it tries to get ID, it will not find anything. This will be an error, and it doesn't know what to do. I mean, we could make a nice error message and say, actually, there was an ID in compile time scope, but you're not allowed to use it because it's a mutable variable in compile time. So this is roughly the idea. I know it's a bit of a complicated setup, and it might not be very straightforward to understand what's going on. I will likely make actual videos where I go step by step and implement some of the things, but I just wanted to get this one out to give you an idea of where things are heading and what my thoughts are around this topic. I guess that's all I wanted to say for today. Hope that makes sense. If you have any questions, please leave them in the comments below. I will be happy to answer them. With that, thank you very much for watching, and hopefully see you next time.